Hi, this is Jim Bergman with Imperial Tools. We've shown you a lot of residential applications with the iManifold. We thought we'd take a little time today and show you some commercial applications and specifically how you can do tests on 4 circuit at once on a large piece of equipment. So I have a 60-ton rooftop unit here, 4 compressors. We've got all the probes attached already. I'll walk you through how we have them attached, and then we're going to go ahead and start up the system and show you how the iManifold performs on a larger commercial system. So we got 4 circuits of refrigeration here. We've got low pressure probes hooked up on 3 of the circuits and high pressure probes, and then to the other circuit here we have the iManifold attached. So we've got 4 different circuits, and we're monitoring the suction pressure, the liquid pressure, the discharge line temperature, and doing that all the way around. So circuit 4 is here, circuit 3, circuit 2, and circuit 1. And we're going to go ahead and start this guy up, and we'll look at all the pressures, temperatures, and show you how the multi-circuit mode works. One of the best things about using the iManifold in commercial applications like this is because we have a fully wireless system, you can put all the probes inside the unit, and where I'm standing at right now is inside the condenser, or reaching inside the condenser. I can actually shut this door completely, not have hoses hanging outside the door, no chance of cutting my hoses, and I'm outside of the unit where it's safe, where I'm not going to bang my head on a condenser fan or burn myself on piping. So it allows me to do all the testing externally, make sure everything's working the way it should work, and I can do it a lot safer and a lot faster. So right now we're looking at 8 wireless probes, and I'm going to go ahead and open these up, but notice right away you got your batteries, you got your green and yellow indicator lights showing you that all the probes are communicating. And if we open these probes up, you can start to see our supply air, wet bulbs and dry bulbs, and relative humidity. All the probes are mapped. I'm going to go ahead and open up our high and low pressure probes, and we can scroll through all those and we can see everything before we start the system. Now the important thing to remember with this is that the first circuit is the iManifold, the second circuit is the next low and high pressure probe, the third circuit is the following high and low pressure probe, and then the last set is probe 7 and 8. So we're looking at low and high pressures, suction line temperatures and superheats for each circuit individually, and then obviously we have discharge line temperature on the 3 discharge lines, and the 4th one is the iManifold. So you won't see the 4th circuit here because these are all just wireless probes. If we go back to the iManifold itself, then we'll be able to see, we'll scroll through here just a minute. I'm going to go back to the active temperatures. So active temperatures here are displayed now. Now the active temperatures are the active temperatures for the circuit that we're looking at on the home screen. So right now, if I tap this, you can see we have circuit 2 as the circuit we're monitoring. If I go back to iManifold, we're going to be looking at circuit 1. So this is the pressure, high and low, for the low side and high side, and saturation temps. We're showing a little bit of superheat on there, suction line, liquid line, discharge line, and outdoor air. If I tap on either side of the seashells there, I can go to circuit 2, see what circuit 2 is doing, circuit 3, and circuit 4. So we're going to go ahead and start the machine up here in a second, and I'll walk you through step by step what we're looking at as we go. So we got the entire machine up and running now, and we're looking at the circuit 1 on the machine. And it'll run diagnostics on each circuit individually. So if we go over here to tools, you can see I have troubleshooting turned on, and right now we're getting an indication on the circuit 1 that there's a problem. We'll tap that on there, and it's indicating that we have low airflow. And you can see here we have the low airflow indicator, but it's also indicating low suction, low superheat, and low subcooling. So each circuit can be diagnosed individually as we go. If we tap that again, that'll go away for now. So you can see we're looking at definitely have the low suction. Superheat looks like it's in the right range. Airflow is indicating low. Now this is a commercial rooftop, so we're using airflow for a typical air conditioning coil. If this coil is designed for a high latent capacity, because this is a gymnasium unit, it may have a little bit different operating characteristics that you'd have to take into account. But right now, based upon standard coil design, it's showing the airflow is low. We could actually go in and look at performance for a second here. And you can see it's about 347 CFM per ton we're moving, or 20,000 CFM. And the deviation from target temperature split is 5.3 degrees. So I'm going to go back to the iManifold for a second, and let's look at the other circuits. So if I just tap on either of the clamshells under, I'm going to go to circuit 2. And circuit 2 now looks like it's running pretty good. And you'll notice the trending stopped, and the trending stops when you go to a new circuit, so it starts trending the next circuit. So on this circuit here, again we have indication, if we tapped it again, that we have low airflow. This circuit's also indicating low subcooling. You can see we have no subcooling right here. Suction and high side pressures look good, but we probably have to look at it and see if we have enough refrigerant in the system. So now we'll go over here, we'll check out circuit 3. Circuit 3, again, no subcooling on circuit 3. Low suction pressure, no subcooling, probably have a little low gas here. We are getting a little bit of superheat back. Discharge line temperature is 185 degrees. Most likely because we have the high suction line temperature, we're not getting great compressor cooling. Let's go ahead and look at circuit 4. And this circuit looks like it probably shut off. We have the low suction temperature or pressure simply because it's an intertwined evaporator and the entire coil is cool, so it's dropping that suction pressure on its own. But we have 105 degree suction line temperature, so obviously something is wrong right there. We want to go back here. We can go back to the iManifold and look at circuit 1. Now if we scroll to the bottom of the display here, we can see our wire temperature, so our suction line, liquid line, discharge line of circuit 1. Our air side, we have 83 degree return air dry bulb, 62 degree wet bulb, 56 supply and 52 return. Slide again, we can see our targets. So our target suction pressure is 83, we're at 75. Target superheat is at 20, we're at 23. Subcooling is at 10, we're at 1.8. 243 and we're at 249. Slide again, we can see on a 60-ton machine we're doing 47 tons of cooling. Again, we have one circuit that's down, so that would account for that at a 26 degree split. Now it doesn't surprise me that overall the capacity is a little higher than you might expect for 2/3 of the machine running, or excuse me, 3/4 of the machine running, simply because we have a really high return air temp, which is going to kick up the BTU capacity of the machine. Slide again, you can see probe 1, 2, 3, 4, 5, 6, 7, and 8. So we're just looking at all the different probes. Now we're back to the active temps. Active temperatures stay active for the circuit we're looking at. So these are the active temperatures for circuit 1. If we tap this, we can go to circuit 2. That's the active temperatures for circuit 2. Tap it again, active temperatures for circuit 3. You notice that the outdoor air temperature is not changing because we're using the same outdoor air for all the machines. Tap it again, we're on circuit 4. So let's say we want to do a report for this machine and we want to set this up and send this out to a customer. I'll show you that next. So we went ahead and measured the voltages and amperages coming in the machine. It's a 480 volt machine. It's got 472, 475, 474 volts coming in. Current's 116, 122, and 131. So we're going to go ahead and submit that data. When you submit that, you can see we're doing 51.15 tons of cooling and about a 7.5 EER. Again, this is a 60-ton machine. One compressor's down. It's not running all that well. It's the first startup of the spring here, so we really haven't looked at it. This is just a reality of what it's doing right now. Now, I want to show you how easy it would be to do a report on each circuit. So we're going to go in here and we're going to go into reporting. And my information's already entered. I'm going to go ahead and enter some customer information. So we'll enter that in there. And I'll just put my email address. And then we're going to go ahead and geotag the address. So you can see we're at South Bedford Road. Use address and submit. So now that's all in. I'm going to go ahead and hit the back key here, and equipment's done. The equipment information, it's a package unit. I can geotag the condenser. So if I want to zoom in on this map a little bit, I can zoom into the, see where we're at on the roof here. And here's my current longitude and latitude. And it's right here's a piece of equipment I'm actually working on. So I'm going to go ahead and drag that over and drop that pin on that piece of equipment, and we'll save the location. So we'll save that location on there. We can select the manufacturer, and this one was okay, this one's not on here. Benman's not on here. So we can go down here to the bottom here, and we'll hit other and Benman. And for sake of time here, I'm not gonna go ahead and put models and serial numbers in. I think you guys could all figure out how we do that. Work perform notes. This is just going to be a equipment service, so we'll leave that the way it is. We'll hit submit and we'll hit back. So we don't need to take any user inputs because everything's already entered in. So we're just going to take a system snapshot. You notice that that's date and time stamped and all the measurements are in. And so now we've taken a snapshot for circuit 1. We can go ahead and tell you what, in the notes here, we'll just put in here edit. We'll call this circuit 1. And submit. So that'll be in our notes on our report. When we hit back and I save and email that report, I'm just going to email it to myself, so I'll save and send, and that report's off. So now I want to go back in and do a report on circuit 2. So I can do a circuit 2 on there. This one looks a little bit better, except we don't have any subcooling. So now I'll go back into reporting. All I have to do is take a snapshot of circuit 2. Again, it's date and time stamped. I'll go into work performed, edit this, just change the 1 to a 2, hit submit, go back. So we can go ahead and save our second report, and that one's sent. So we do this for all 4 circuits. It would just take us about a couple minutes to do that. And on each report here, and I'll just go to my email real quick. We'll go in, you can see that it's coming in iManifold report for Nardonia. So I'll just take the top one here. And on each report, I'd get in all my pressures, my temperatures, my superheat, subcooling, return air dry bulb conditions, my estimated airflow, my tonnage. I'm also showing, again, that this is circuit 2, so I can identify that circuit. I can show you the total EER, 6.93, all of the latent sensible load calculations, and really this makes it very, very easy, very, very quick to do the entire PM on the rooftop unit, get all the information, again, real quickly. And here we are standing out of the sunlight in the shade and making our day a lot easier. So this is just a little bit on the multi-circuit reporting. Hope you got a little bit out of this. It was interesting to do. And this is Jim Bergman with Imperial Tools. Thanks a lot for watching.